Hi, today we are going to explore middleware in Azure Functions by building a real-world authentication system. We will create a login API that generates JWT tokens and then build Azure Functions that use custom middleware to validate those tokens automatically. By the end of this tutorial, you will understand how middleware work in Azure Functions, how to create custom attributes for declarative security, and how to validate JWT tokens in reusable way. Let's dive in. First, let's understand what is a middleware. Middleware is a software that sits between the incoming request and your application's business logic. It acts as a processing pipeline where each middleware component can inspect, modify, or even reject the request before it reaches your function, and can also process the response before it's sent back to the client. Real-world analogy, airport security. Think of middleware like airport security checkpoints. Before you can board your plane, reach your destination or function, in our case, you pass through multiple checkpoints: ticket verification, security screening, passport control, etc. Each checkpoint can inspect you, verify your credentials, or even deny you access. Similarly, middleware checks and processes requests before they reach your application logic. Let's see the middleware pipeline flow. In this example, we have two middlewares, logging and authentication. The order of the middlewares are important and they execute in order. When the incoming request arrives to the business logic execution, it goes through the execution and then falls into the outgoing response flow and executes the middleware in the opposite direction until the last one sends the response to the client. The key insights are each middleware can inspect, modify, or stop the request, or if authentication fails, the request never reaches your function. The characteristics of middleware. Sequential processing. Middleware executes in a specific order, forming pipeline where each component processes the request before passing it to the next. Can short circuit. Any middleware can stop the pipeline and return a response immediately, for example, returning 401 unauthorized without calling the function. Inspect and modify. Middleware can read request data, modify it, add information like user claims, or transform responses. Reusable logic. Write cross-cutting concerns once, authentication, logging, error handling, for example, and apply them to multiple functions. Separation of concerns. Keep your business logic clean by handling infrastructure concerns like authentication, logging in the middleware. Targeted application. Use attributes or configuration to apply middleware selectively to specific functions that need it. Common middleware use cases. Authentication and authorization. Verify JWT tokens. Check user permissions. Validate API keys. Logging and monitoring. Request response logging, performance tracking, error tracking. Error handling. Global exception handling, standardized error responses, retry logic. Request transformation, data validation, request normalization, header manipulation. Rate limiting. Throttle requests, prevent abuse, manage quotas. Caching. Response caching, cache invalidation, and performance optimization. Here I am in Visual Studio, and for our demo today I created three projects. The Auth API project, which is a minimal API for logging and token generation. And we have our middleware function app, which basically is our Azure function that we are going to implement the middlewares in this project. And also we have the shared project, which is a shared models and settings between the two projects. Now let's talk about middleware in Azure Functions. Unlike ASP.NET Core, where middleware is built in, Azure Functions using the isolated worker model require us to implement the IFunctionsWorkerMiddleware interface. Let's start with a simple logging middleware to understand the concept. I created a middleware called logging middleware, and it will log when a request starts, call the next middleware, and log when the request completes, and measures the execution time. Let me show you in the code. So here we have our logging middleware, and we are implementing IFunctionsWorkerMiddleware, which has the invoke function, and also we inject iLogger to the class. When the request comes in, first we log this information about the function name and invocation ID, and then we start a new stopwatch, and then we call the next. Basically, this calls the next middleware in the pipeline, or if not, then it calls the function app function. And then after the function's execution, we stop the stopwatch, and then we log again the information. So basically, this is what our middleware does. Very simple. Here I have a very basic service which is called ilog example service. It has an execute method which is implemented in this class. Also, it's just a log information that I want to show you exactly what happens inside the function. So we are going to use this service inside the function. And I opened the demo function. Here we have this log example function that we are going to send an HTTP request to this function, and this function, and we will see the flow of the execution, how it works. This function simply calls the execute function inside the log example service, and then create a response and just writes this is a log example endpoint and send it back to the client as the successful response. Now let's run the project and see how we can test it. I have a Postman request which I'm going to fire now, and we can follow the logs to see what happened in the code. So this is our console, and we can see that from the first log function invocation ID start the execution. So this was the first log in our middleware, and then this is the log which was generated inside the function itself, and this was the log also that was generated in the service. And then when the function ends, we have here the last log from our middleware with the invocation ID. And basically that's it about the log service, and you can see the power of the middleware in this case. In our demo for today, we have the auth API, which is responsible for generating the JWT token. The client sends the username and password to the auth API, and then auth API responds back with the token, and then the client sends the token to the Azure function, and Azure function responds it back after validating the token. So let's see it in the code. In auth API, we have the login endpoint. For this demo, we will use a simple hard-coded user validation, but in production, you would check against a database. The key here is generating the JWT token with the claims like username and role. We are using the JWT security token handler to create a token with subject claims like email, username, role, expiration time for 1 hour, signing credentials using a symmetric security key. Let's see this in the code. Inside the auth API, we need to install Microsoft ASP.NET Core Authentication JWT Bearer NuGet package. And then in our shared project, we have a JWT setting object which has our secret key. It is just a random text. And we have our issuer, which is the auth API, our audience function app, and the expiration minutes. We will use this class in both auth API and middleware function app. Next, we have our logging request, which we accept username and password in our API. And then as a response, we have our logging response class, which returns back a token and also the expiration date. Let's head back to our program class and see what we have here. We create a new instance of JWT settings and we add it to the dependency injection here. And we add our authentication to our dependency injection and also other related services as well. Here we have our endpoint, which is logging. With the post method, we accept a logging request, and we have here two block, which basically checks the user input with the hard-coded value. One of them is admin and one of them is user with the same password. And if none of them was basically provided in the request, then we return unauthorized response. Here we have a method which basically creates the JWT token. We got a username and also role. And here basically are JWT settings. We create an instance of symmetric security key based on the key that we have in our setting object. And then we create a signing credential object. Then here we add our claims, like name claim is our username, email, and role. And also here we just create an instance of JWT token and we just return it back. Let's fire some Postman requests to see how it works. I will run the project. And we can use our get token HTTP endpoint, which I created in the Postman already with the username user and this password. And we have the token now. And also we can check it with admin username and also we got the token. If I put here something wrong, then we have our unauthorized 401 response message. So let's grab this token and see what values are included. So I copy the token and we open jwt.io in the browser. If I paste the token here, we can see in the name claim we have admin, in our email address admin domain.com, and in our role is admin value. Now let's take a look at our middleware application. We need to install system.identitymodel.tokens.jwt NuGet package. Then to make our middleware flexible, I created a custom attribute called required auth. This allows us to declaratively mark which functions need authentication. This is a simple marker attribute that our middleware will look for. When a function has this attribute, the middleware will enforce JWT validation. This attribute can pass down roles as extra information to middleware to be able to also check against the user's role claim, as we will see in the code. Let's review the middleware. Inside middleware's folder, we have JWT middleware. It implements IFunctionsWorkerMiddleware, and also we inject a JWT settings object, which holds the information about the token. We need to implement the invoke method from the interface, which has a function context object, and this object holds extra information about the executing function. For example, we can extract from here what is the name of the calling function, for example. We have here get target method, which does exactly that with the help of reflection, and it returns method info object to the caller. After that, we have here extract token, which, as the name implies, extract the token from the header of the request. And we have also another function which validates the token. And at last, we have two other functions which are creating our response: create unauthorized response, create forbidden response, as we will see now in the code. So first step, we get the extra information about the calling function, and then we check for the attributes. I mean the marker attribute we just saw. If the attribute was null, then we just pass the execution to the next middleware or simply to the function. And next, we just try to fetch the HTTP request data. If also that was null, the same, we just pass the execution. Next step is that we extract the token from the authorization header. And if the token was empty, we just return the unauthorized response, as we can see here. Next step is to validate the token, and also if the token was not valid, we just return the unauthorized response here. Here, next, we check if a role was provided in the attribute. If yes, then we need to check our token if the token contains the appropriate roles. If the token doesn't have the required roles, then we need to create a forbidden response object to the client. If everything was fine, then we add the claims to the context and we pass the execution path. I have an extension method for our context, if we can check it here, which sets the HTTP response data in a different way because we are in the middleware, and we use this extension to do this job for us. And also we have another function which returns the claims principal of the user. So let's see our program class. In the program class, we register our JWT setting class and also our service, log example service, which we saw in the log example, and also our two middlewares, JWT middleware and logging middleware. The order matters. And now we can go on and check our functions. Here we have three other functions, which is called public function, protected function, and admin only function. The public function doesn't have a required auth attribute, so we can basically call this function publicly and get the response back. It just logs some information and create a response and just write something to the response, and we can check this in the Postman. Let me start the project. So here we have public example get method. I will send, and we simply get the response back without any authentication required. Our next function here, protected function, has the required auth attribute. This means that we have to provide the token here. And for that, I will run also auth API. And inside the Postman, we try to call the login function. I log in with user and with the username user and password 123. We grab the token and then we go to our protected get endpoint, and here under the authorization we just put back the new token and we call this function. So it was able to get our username and also the role from the user claims that just a minute I can show it to you. Here from the context with that extension method that I showed you, we are able to extract our claims, and then we create a response and we just include those information to the response in the protected function. But what happens if we don't provide the token here? We can check that if I remove the token now and we just send a new request, we get the appropriate response missing authentication token. In our next function, admin only function, we are passing in the required auth and the role of the calling user. So the user needs to be in the admin role to be able to send a request to this function. And also we can check it if now we go to Postman, I will try to send the token that we got from the user, from our user with the username, because that user doesn't have the admin role, and we should get here some sort of error if we try it out. We got exactly insufficient permission as we could expect. So now I try to again log in with the admin user. And again, let's try it out. And this time, hopefully, this should work. And there we go. Okay, we have built a complete authentication system using middleware in Azure Functions. The key takeaways are: middleware in Azure Functions allows reusable cross-cutting concerns. JWT tokens provide stateless authentication. The isolated worker model gives you full control over the pipeline. This pattern can be extended for other concerns like global logging, rate limiting, global exception handling, or custom authorization rules. The complete source code is available in the description. Thanks for watching and see you in the next one.